right, so now we're going to learn about compound inequalities. A compound inequality is a statement that consists of two inequalities joined by the words and or. Now, if you have an and compound inequality, then your solution would be a number that makes both of your inequalities true. So for example, this is what an and compound inequality looks like. Sometimes you might see it as x is greater than -2 with the word and in between the two inequalities, but most of the time you would see it written like this. And what this reads is that x must be greater than -2, but also must be less than 3. So any number basically in between -2 and 3 would satisfy both of your inequalities. An or compound inequality is when your solution is a number that makes either inequality true. So you will see an or inequality solution look like this. It's just two inequalities with the word or in between them. And so this reads that x can be less than 0 and x could be greater than or equal to 2. Now, if x was -1, that clearly only satisfies one of our inequalities and not the other. Or again, if x was a value of 3, that only satisfies one of these inequalities, not the other. But that's okay because of this word or. It must satisfy just one of the inequalities. Whereas in the and inequality, if you had the number 0, that actually satisfies both inequalities. It satisfies 0 is greater than -2 and 0 is less than 3. And the reason why it must satisfy both of the inequalities is because of that word and, which you don't see here, but this is an and compound inequality. All right, so we're going to get started. Number 1, as you can see, this looks more like an and compound inequality because at my middle, x plus 5 is being greater than -5 but less than 5. So what I'm going to do is I'm going to solve for x, and x is attached to that plus 5 in the middle. If I'm going to subtract 5 from the middle, I need to subtract 5 from all 3 sides. So this is a little different because in an equation you only have 2 sides. In an and compound inequality, you have 3 sides. And we want to subtract it from all 3 sides. So I wind up with a -10 is less than x, which is less than 0. And x is isolated, so this is my solution. And so now I'm going to graph this. I'm most likely going to need to go by 2's to fit -10 and 0 on the graph. Okay. So what this means is I'm going to have an open circle at -10 because there's no equal to symbol. I'm going to have an open circle at 0 because there's no equal to symbol. And I want x to be greater than -10 but also less than 0. So what that means is I shade in between my two numbers like that. Number 2 is also an and inequality because it's in the format of the and inequality, and so I'm going to isolate x by first subtracting 4 from all 3 sides. When I subtract 4 from all 3 sides, I get the following. But then x is still not isolated. I'm going to need to divide by 3 on all 3 sides. And so x must be in between -1 and 2, including -1. So I'm going to graph this now. I will have a closed circle at -1, an open circle at 2, and I want x to be greater than -1, but less than 2, so that means I'm shading in between my two numbers. All right, number 3 is an OR compound inequality. So I'm going to solve both of these inequalities separately. The first inequality, I'm going to add 3 to both sides. I get k is greater than 4, and then I join with the word OR. In my second inequality, I'm going to add 3 to both sides, and I get k is less than 1. So I'm now going to graph on my number line. I'm going to have an open circle at 4, an open circle at 1, and I want k is less than 1, so I shade this way, and I want k is greater than 4, so I shade this way. So for inequalities, your shadings are split, whereas and inequalities, your shadings intersect, but you don't shade past the dots. All right, we are going to move on to number 4. So we're dealing with another OR inequality. I'm going to solve both of these inequalities for b. First one, I'm adding 2 to both sides. And I have b is, not equal to, greater than 20. And then OR, in my next one, I'm dividing by 3 on both sides. So I get b is less than or equal to 18. So, graphing this now, I have an open circle at 20 and a closed circle at 18. I want b is greater than 20, so I shade to the right on that one. I want b is less than or equal to 18, so I shade to the left on that one. So, this is my answer. And since it was an OR inequality, you see that the shadings went the opposite directions. All right, so number 5 is an AND inequality. We're going to start off by subtracting 9 from all 3 sides. When I subtract 9 from a -6, I wind up with a -15, which is less than a 3y, which is less than a -3. I'm now going to divide by 3 on all 3 sides, And I wind up with a -5 is less than a y, which is less than a -1. So now I'm going to graph this. And I wind up with an open dot at -5, an open dot at -1. I want y to be greater than -5. I want y to be less than -1. So I'm actually shading in between the 2 dots, and I don't move past the 2 dots. That's my shading. All right, number 6 is an OR inequality. I'm going to start off by subtracting 8 from both sides in my first one. When I subtract 8 from both sides, here's what I'm left with. And my second one, I actually can just divide by 6 on both sides. In my first one, going back to my first one, I need to divide by 5 on both sides. I wind up with that. All right, so graphing this now. I would have a closed circle at 3, an open circle at 8. I want m to be less than or equal to 3, so I shade to the left, and m to be greater than 8, so I shade to the right. I'm going to write my answer as m needs to be less than or equal to 3, or, because of that little or here, m can be greater than or equal to 8. All right, moving on to number 7. This is an OR inequality. So we're doing the same thing. I'm going to subtract 5 from both sides. I have a negative y is less than or equal to a 4, then I divide by a negative 1. A reminder, when we divide by a negative number in an inequality, the inequality symbol flips. In my second one, I subtract 4, then I divide by 3, and I wind up with y is less than negative 3. So I'm going to graph this now. All right. So I have a closed dot at negative 4 and an open dot at 3. So y is less than or equal to negative 4 means I shade to the left. Y is less than negative 3 means I shade to the left. So this is a new one. Remember, your answer just needs to satisfy one of the inequalities, and since the shaded regions intersected, that means that we're only going to have one inequality solution here, and since it only needs to satisfy at least one of these inequalities, y is less than negative 3, any number less than negative 3 would satisfy at least one of these inequalities. So that is your solution. You just leave it like that. Your answer is not a compound inequality for number 7. Now, number 8 is an and inequality. I'm going to subtract 4 from both sides, or from all 3 sides. I get a negative 7 is less than or equal to a 7c, which is less than a 14. I'm now going to divide by 7 on all 3 sides, and I get negative 1 is less than or equal to c, which is less than 2. So graphing this now, I have a closed circle at negative 1 and an open circle at 2. I want to shade in between. That's my solution. All right, moving on to the next one, which is an and inequality. I'm going to subtract 2 from both sides of my first one. Subtracting 6 from both sides of my second one. So I have a closed circle at negative 12 and a closed circle at negative 7. I want n to be greater than negative 12 and n to be less than negative 7, so I shade in between. I can either write it with the and symbol in between, or I can write it as this compound inequality, like this. That's my answer. All right, moving on to number 10. I'm going to divide by 4 on both sides, for all 3 sides. This is an and inequality. I wind up with a 3 is less than an n, which is less than or equal to a negative 10. Now this one's going to be tricky because I have an open circle on 3, and I want all the numbers greater than 3. And I have a closed circle on 10, and I want all the numbers less than or equal to 10. This is an and inequality, and the shaded regions do not intersect. And when that happens in an and inequality, this is actually no solution. All right. Number 11 should actually just be a less than or a greater than symbol, no equal to symbol here. So we're going to start to solve. And I wind up with p is greater than negative 8 and p is greater than 1. 1 is also tricky. I have an open dot at negative 8 and I'm shading the greater than, so all the way this way, and an open dot at 1 and a greater than, so I'm shading this way. The 2, since it's an and, we want the intersected shaded regions, which would actually just be p is greater than 1. So that's your answer. So your answer isn't a compound inequality, it's just this. I'm going to have you try number 12 on your own. Since this is an or inequality and all my shaded region covers the whole span of the number,